Hey everybody, I'm back, and this time we're going to measure volume of an irregular object. Now, in the first part of our volume video, we measured something that had nice, easy to measure sides. So for instance, we measured this rectangular block right here. But every now and then, you're going to get an item such as this. This is a basic rock. This item, you guys, is much more difficult to measure. So if I wanted to measure the volume of something like this, it's not going to be easy for me to measure the length, the width, or the height of this because, well, it's kind of hard to figure out where the length, the width, and the height is in something like this. So we have to use a different method. And the method that we're going to use is finding the volume of an object by water displacement. Now, again, you guys remember, the definition of volume is the amount of space that an object occupies. In this case, the object is a rock. Okay? So what I need you to remember is that this object will displace any sort of fluid. Fluids include both air and liquids. So look what I have here. What I have a graduated cylinder, and in this graduated cylinder I have put a quantity of water. And though it might be a little bit hard to see from the video, but this quantity of water right now is sitting at 21 milliliters. Now let's keep track of that. Let's go ahead and write that down. So what we have is we have our starting volume of water. Our starting volume of water is 21 milliliters. Okay, and I'm going to go ahead and use ml as an abbreviation for milliliters. So that's important for me to keep track of. Now, what I want you to remember is that we're going to go ahead and put our rock into the graduated cylinder, and this rock is going to displace this water, meaning it's going to move the water. So when you do this, you want to be careful, and I'm kind of doing this one-handed because my other hand is on the camera right now, but you want to be careful. So you want to kind of tip your graduated cylinder to the side a little bit. You don't want to spill the water, and then gently drop your object into the water. You want to make sure that no water leaves the graduated cylinder. Now, what we're going to do is we're going to take a close look again, and what we're going to do, and this is really important, is that you don't want to look at it from up here and try to figure out what the volume of water is reading now. You actually really need to get down right here at eye level, and then you need to read, you'll see how the water kind of curves a little bit. That's what we call a meniscus, that very bottom part of the curve. So when you are reading this, you want to make sure that you are reading it, you're getting down really low on it so that you can read it right at the bottom of the water level. So now our water level is reading, when we started, remember, it was 21 milliliters. Now when we read it as, here's 20 milliliters, 21, 22, 23, and now it's reading at 24 milliliters. So let's go ahead and write that down. Our end volume of water equals 24 milliliters. So that rock, this little rock in here, it actually displaced 3 milliliters of water. How do I know that it displaced 3 milliliters of water? Well, if I take my end volume, what we're going to call EV, minus my start volume, which I'm going to call SV, equals the final volume of whatever object I put in the water. In this case, the object I put in there was a rock. So my ending volume was 24 milliliters minus my starting volume, which was 21 milliliters. 24 minus 21 equals 3 milliliters. So if I want to know the volume of my rock, that's the volume of my rock right there. Because what that means is that that rock displaced 3 milliliters of water, which means that rock has a volume of 3 milliliters.